Ladies and gentlemen, this is the Resins portion for the Senior Comprehensive Exam Study Guide. This is going to go over some of the structure-property relationships that I would like you to have learned and remembered as part of resins. There will be a part that has to do with thermoplastic resins, and there will be a part that has to do with thermoset resins. And so I'm going to hint very heavily about what I'm going to ask you over the two portions. One 10-point question focuses on thermoplastics, the other one focuses on thermosets, but really it's thermosets versus thermoplastics in terms of properties. So the first section has to do with the effect of crystallinity on a thermoplastic. So you may recall this slide from the crystallinity lecture in thermoplastics. Do I expect you to know all of it? No. What I actually expect you to know is whether or not crystallinity affects transparency. And it does. An amorphous plastic tends to be transparent. In other words, you can read a newspaper through it. Or a semicrystalline plastic tends to be translucent or opaque. Now, translucent means light passes through it, but if you try to read something through it, it's going to be blurry. Or opaque. In other words, no light passes through it, you can't see anything through it. So that's the first thing I want you to consider, is what crystallinity has to do with transparency. So then we're going to take a look at two different clear plastics. The first one is polystyrene, the other one is polymethyl methacrylate. Now here are their structures. Polystyrene is classified as a commodity thermoplastic. Polymethyl methacrylate is classified as a quasi-commodity thermoplastic. So we already know there's a difference in those two. We see the structures are different, we see that their price points are different. The thing that is the same is that they are amorphous. Now what that means is they're clear. Both of them are clear. You can read a book through these plastics. There's another difference. Polystyrene is not well suited to exterior applications. UV light causes yellowing, and that is caused by interactions of free radicals with these pendant phenyl rings. So it rearranges this, causes chain scission events. Not good. The plastic gets yellow, it gets brittle. Not good for exposure to UV light, therefore not good for exterior applications. Honestly, not good for anything where UV light contacts polystyrene, and this includes anything that contains styrene as a monomer, like ABS. If you have appliance parts, I have a washing machine that had some ABS around the top of it, and it was in front of a window. It will yellow over time. I have a baby gate that's the same way. So if there's any exposure to UV light, that styrene, even if it's in monomer form in like a terpolymer like ABS, will cause yellowing. Polymethyl methacrylate does not yellow. That makes it very well suited to exterior applications. Polymethyl methacrylate is sometimes used in place of glazing applications, in other words, instead of glass. So UV light can pass through it, it doesn't yellow, it retains its properties. And the properties that both of these have is that nice amorphous glass-like appearance. So if I'm asking you to choose between these two, consider these particular things. Are they clear? What's their price point? Are they suited to exterior applications? And if they're not suited to exterior applications, why are they not suited to exterior applications? So that's what I'm asking you for thermoplastics. Now, when it comes to thermosets, I'm really asking you to make distinctions between the two. And I'm asking you to make distinctions between the two based on recyclability, and so that's the first thing. In other words, how does a thermoset recycle? Well, the answer is it doesn't. First, it forms an irreversible chemical bond. Irreversible, meaning it doesn't go back again. And therefore, you can't remelt it. These will degrade before they melt. Sometimes they'll soften, but you'll eventually get them to degrade before they actually melt. A thermoplastic, of course, doesn't do that. The way this cures is basically just by freezing it, cooling it down. There's no chemical bonding that takes place in a true thermoplastic. That means you can recycle a thermoplastic. So that's the first distinction I'm asking you to make between thermosets and thermoplastics. The next one is, how do these materials gain strength? How do they grow their strength? In a thermoplastic, it's usually high molecular weight, and if the plastic has the ability to form crystalline regions, some amount of crystallinity. Not all thermoplastics are semicrystalline, of course, but most of them are high molecular weight. That's why they're solid at room temperature, because they're high molecular weight. And some of them are also semicrystalline. If they are amorphous, then they're clear. If they're semicrystalline, then of course they are translucent or opaque in their natural state. An amorphous plastic can be made opaque, of course, by introducing colorants or other additives. And when it comes to a thermoset, they build their strength through cross-link density. They will eventually have high molecular weight, but you usually start with a low molecular weight species that then grows molecular weight by cross-linking in a three-dimensional network. That three-dimensional network prevents crystallinity from happening. So these tend to be very strong because they cross-link in multiple directions. They have high molecular weight, but a fully thermoset part could be, in theory, one molecule, whereas something with a thermoplastic has high molecular weight, but it's many, many polymer chains. And so it's that cross-link density that prevents recycling because it won't melt. It's just too high. But that high molecular weight, even though it's high in a thermoplastic, can still melt. So that is how a thermoset versus a thermoplastic gains strength. Thermoset, cross-link density; thermoplastic, high molecular weight and or crystallinity, presence of crystallinity in the overall semicrystalline material. The next one is properties. What advantages do thermosets have over thermoplastics? What advantage do thermoplastics have over thermosets? Well, if you're considering the exact same classification, so let's say a commodity thermoset versus a commodity thermoplastic, when you're looking at a commodity thermoset, you're looking at something with enhanced mechanical properties, enhanced chemical resistance, enhanced heat resistance, and better structural integrity and resistance to deformation as the thermoplastic at the same price point. So think of a phenolic versus a polyolefin. So your phenolic thermoset versus a polyolefin. The thing that the thermoplastic has at that same price point that the thermoset doesn't have is much better bendability, flexibility, ductility. Thermosets tend to be much more brittle at the same price point than the thermoplastic, which can be much more flexible. So when asking you to compare the properties of these two things at the same price point, thermosets provide significant improvement in many areas, whereas thermoplastics tend to be much more flexible, and that's where they become advantageous for things like films, flexible packaging, things like that over a thermoset material. So please look over the PowerPoint. This will also be uploaded to the study guides. Some general information about the comprehensive exam. This will go live on April 20th at noon, and it will be available through May 5th before 11:59 p.m. I ask that you please get this done as fast as possible. These are essay or file upload questions, so they won't be automatically graded in Canvas. Therefore, they have to be downloaded, and then the individual professors will have to grade their sections. So if you don't complete it by the time that it is due, it creates a problem for us to get your score to you in a timely fashion. We have to get grades in by the end of finals week. So please do this at your earliest convenience so that we can distribute the sections to the various professors, and then they can be graded in an expeditious fashion. So if you have any questions for me regarding the Resins portion, please feel free to ask. If you have any questions about the general format of the exam, also please ask. You know you can get a hold of me by phone, text message, Canvas message, or email. So please use all of those avenues available to you, and good luck on your comp exam.